Salam, peace be upon you. You run errands in a city you know well. You leave your home, you walk to the bank, you walk from the bank to the market, you walk from the market to the post office, and then you return home. When you step back through your door, you don't experience it as four unrelated walks. You experience it as one composed morning. Each piece mattered because it connected to the next. Each piece ended where the next piece began. If one segment ended on one side of the city, and the next segment somehow began on the other side, with no road between them, you would not call it a composed plan. You would call it a broken story. That ordinary feeling. These journeys can be joined, therefore they form a single, meaningful journey, is exactly what we install now as strict grammar in the Pure Phi language. We are not adding any physics furniture. We are not adding particles or fields or space-time or energy as substance. We keep the discipline from the beginning. Energy, whenever it later appears in the larger project, is a tally or report, not an ontic thing. Here we are doing something quieter and more severe. We are freezing a rule of language that cannot be cheated. If loops are meaningful tokens, they must compose like a language. Otherwise, global meaning becomes poetic, and poetry cannot be audited. We arrived here step by step. We built clean domains where derivative speech is legal. We declared excision, so we can say, without embarrassment, our calculus lives here and not there. We installed orientation, so sign is not a mood, but a declared convention. We saw closure forcing discreteness. When you traverse a closed loop inside a clean domain, the total phase change must be an integer multiple of a full turn. We then wrap that phase change into a native circle token called holonomy, a memory token that lives directly on the unit circle. Now the next question is unavoidable. If you can traverse one loop and then traverse another loop, what is the memory of the combined journey? If two loops are words, how do we form a sentence? Hold an image in your mind. A ribbon on a table. You twist it once. Then you twist it again. You can call those two twists two actions, but the ribbon records them as one combined twist state. If you twist and then twist again, the total twist is the composition of the two twists. If you twist and then you untwist, the ribbon returns closer to its original state. The ribbon is not doing mathematics. It is simply enforcing consistency. Actions in sequence accumulate into a combined result, and the combined result must not depend on how you describe the sequence. That is loop composition algebra. It is the grammar that turns loop tokens into a computable language. Let's name the objects carefully and keep everything inside PS0. We have phi, the only primitive. Phi maps x to S1, meaning each event in x is assigned a phase on the circle. X is just the minimal support that lets us talk about patches and overlaps. We forbid absolute phase. Anything that changes when phi is shifted by a constant is not semantic. To speak calculus, we choose a local lift. We choose a real-valued function phi tilde defined on a patch where it is valid, such that phi equals phi tilde modulo 2 pi. Then we define the first derivative word. A equals d phi tilde. A is the change word. It is the object from which the triunity readouts come. Omega, kappa, nu are three inseparable echoes of A, never independent primitives. Even when we talk globally about loops, we remember this. Whatever we do is constraining A, and therefore constraining the tri-echo together. Now define a loop. A loop is a path gamma that starts at a point in our clean domain D, travels through D, and returns to its starting point, without crossing the excised regions. We also declare orientation. We decide and declare which traversal direction we call positive. That orientation is part of the meaning because it fixes sign. Now define holonomy in a way that can be spoken cleanly. Holonomy is the unit circle memory token of a loop. For a loop gamma, we define h of gamma as follows. Take the closed loop integral of a along gamma, and then wrap it back onto the circle by taking the exponential of I times that integral. Spoken carefully. H of gamma equals exponential of I times the loop integral around gamma of d phi tilde. If you prefer to say A, you can say h of gamma equals exponential of I times the loop integral of A along gamma. The output lives on the unit circle U1. U1 is simply the set of phases, all complex numbers of magnitude 1. It is the natural home for phase memory because phases are cyclic. A full turn returns you to the same point on the circle. Now we come to the core rule of this part. Suppose you have two loops, gamma 1 and gamma 2, both based at the same starting point, both entirely contained in D, both with declared orientation. You traverse gamma 1, return to the base point, and then immediately traverse gamma 2 and return again. That combined act is itself a loop. We write it as gamma 1 composed with gamma 2. The composition symbol means do the first, then do the second. It means after. It is not a decoration, it is a claim about sequence. The composition rule says h of gamma 1 composed with gamma 2 equals h of gamma 1 multiplied by h of gamma 2. Let me say that again in plain language. The memory token of doing two loops in sequence is the product of the memory tokens of each loop. And there is a second rule, the undo rule. If gamma inverse is the same loop traversed backward, then h of gamma inverse equals the inverse of h of gamma. Spoken, the memory token of the reversed loop is the reciprocal of the memory token of the original loop. These two rules are the loop composition algebra. They are not optional. They are forced by two facts that do not require any physics assumptions. First fact, line integrals add when you concatenate paths. If you walk one path and then another, the total accumulated integral is the sum of the integrals on each piece. Second fact, the exponential map turns addition of angles into multiplication of phases on the circle. Exponential of I times A plus B equals exponential of I times A multiplied by exponential of I times B. So because integrals add, and because exponentials convert addition into multiplication, holonomy must multiply. That's the deepest simplicity of the rule. Addition inside the integral becomes multiplication after wrapping back to the circle. If you want to hold it in your body rather than your head, hold the image of rotations. Rotate your hand 30 degrees, then rotate 60 degrees. The total rotation is 90 degrees. If you represent your hand's direction as a point on a circle, then composing rotations corresponds to multiplying the circle points. It's the same fact in two encodings. Angles add, phases multiply. Now in part 18, we also spoke about winding, the integer token forced by closure. Winding is the statement that the loop integral of d phi tilde equals 2 pi times an integer n, provided the loop is in a defect-free class inside D and the sentence is well-formed. When you compose loops, those integers add. One loop winds n 1 times, another winds n 2 times, and the composed loop winds n1 plus n2 times, because the integrals add before you ever wrap them. So winding adds under concatenation, holonomy multiplies under concatenation. That is not two separate laws. It is one law seen in two different representations. Integer counts for full turns, and circle tokens for the wrapped remainder. Now I want to show you why this is not math for its own sake. This algebra is the first global consistency test that prevents cheating. It turns global tokens into a language that can be audited, decomposed, recomposed, and checked. If your claim token changes when you chop a loop into different segments, you have not discovered new structure. You have written an ill-formed sentence or crossed the boundary without declaring it. To make that concrete, let's walk through the four gates in a way that feels like ordinary honesty, not bureaucracy. First, the well-formedness gate. In this part, well-formedness means you can only compose journeys that actually connect. Composition is typed. The endpoint of the first path must equal the starting point of the second path. If you attempt to compose two loops that are based at different points without first transporting the base point, you are smuggling in a jump. In PS0, jumps are not allowed. X is not assumed to have any hidden teleportation structure. You must show the connection in the domain. For based loops, this is easy. Both begin and end at the same base point, so gamma 1 after gamma 2 is well typed. But the moment you try to compose more general paths, the gate matters. You cannot say, I walked from my home to the bank, and then I walked from the market to the post office, and pretend those compose, unless the bank is the market. If the endpoint does not match, you do not have composition. You have a collage. This is the recipe rule in a kitchen. You cannot compose mix dry ingredients with pour into oven, unless you have a batter to pour. If you skip the step that creates the shared state, the composition is ill-typed. The cake doesn't fail because the universe is strange. It fails because the sentence you enacted was not well formed. Second, the invariance gate. The composition algebra must be independent of how you represent the loops. You can traverse the same loop quickly or slowly. You can parameterize it in 1,000 ways. You can break it into 2 segments, or 10 segments, or 100. If the holonomy token depends on how you chopped the loop, then holonomy is not a token of the loop. It is a token of your description. That would violate the entire principle of representation independence we installed earlier. So invariance here means if two descriptions represent the same loop class in D, then their holonomy must agree, and the multiplication rule must give the same result regardless of which admissible decomposition you choose. You already demand this in ordinary accounting. If you pay £100 as one transfer or two transfers of 50, the total is the same. If the bank's ledger gave different outcomes depending on how you partition the payment, the ledger would be unusable. The partition must not change the invariant. The composition algebra is the same demand, but for loop memory tokens. Third, the domain gate. The algebra is defined only where the tokens are defined. Holonomy is defined for loops in D, where A equals d phi tilde is legal. If any component of a composed loop leaves D, crosses an excised neighborhood around a defect, touches a boundary color where the sentence was not licensed, crosses a declared cut without proper bookkeeping, then the holonomy for that component is not a legal token in this part. And if you do not have legal tokens for the parts, you cannot multiply them to get a token for the whole. Arithmetic on undefined objects is not insight, it is noise. This is not stubbornness. It is the whole point of excision. Not to avoid hard places, but to say honestly where the grammar changes. You cannot demand the algebra of safe driving in the middle of the ocean. You need a different grammar there. Similarly, you cannot demand the algebra of lift-based integrals across a region where lift fails. That is later defect grammar, not here. So the domain discipline in this part sounds like: before you compose loops, declare that each loop lies inside D. If not, you must either excise more carefully or change the type of sentence. Otherwise, your composition claim is not a sentence. Fourth, the non-encodability challenge. Now that we have winding and holonomy, and we have their composition algebra, we have a powerful toolkit for global tokens. So if someone proposes a new topological token in PS0, the first challenge is immediate. Does it respect composition? If it is truly a loop token, it must assign to a composed loop a value that is the composition of the values. It must have an identity for the trivial loop and an inverse for the reversed loop. If it fails these, it is not a valid token of loops in this language. And if it does respect composition, the next challenge is, can you express it as a function of holonomy, winding, defect charges, and jet constraints? If yes, it is not a new primitive. It is a repackaging. That is allowed, but it is not an ontic addition. If no, then the proposer must prove non-encodability, that their token cannot be reduced to the existing alphabet. That burden is heavy by design. It keeps the language minimal and coherent. Now let's keep triunity alive, because it is easy to forget it when loops enter the story. Composition is not a geometry trick. It is an accumulation rule for A, the change word. When you traverse a loop, you are accumulating A along that traversal. When you traverse two loops in sequence, you are accumulating A across both traversals. Because omega, kappa, nu are readouts of A, the composition law is telling you the triaco accumulates consistently across joint journeys. If you claim that holonomy of the whole is not the product of holonomies of the parts, you are claiming that A cannot be tracked consistently under concatenation. That would mean either you change your lift inconsistently, you change charts without applying the proper transformation rules, or you left the legal domain. In other words, composition failure is not a mysterious physical phenomenon inside PS0. It is a sign that your sentence is ill-formed. Now let me scatter examples across scales, but each time I will tie the example to one specific piece of the algebra, so the listener never loses the spine. Start with human everyday reality. Think of a conversation that returns to calm after tension. You say something sharp, later you apologize. The apology is intended as the inverse traversal. It aims to undo the phase shift introduced by the sharp word. If the apology is sincere and lands, you feel the loop close back toward its starting phase. Trust is restored. In the algebraic image, harm followed by repair approximates the identity token. If instead the apology makes things worse, then it was not the inverse. It was another loop, and it multiplied a new phase shift on top. The point is not to turn life into equations. The point is to see how the grammar of undo is a deep structure. Reverse a loop, invert the token. If undo fails, it is telling you there was a domain issue. Maybe trust was already torn. Maybe you crossed a boundary that cannot be uncrossed in one step. Domain changes make inverses non-trivial. Now, history and behavior. Consider a political cycle. A society passes a reform. Later, it passes a counter-reform. In simple narratives, people say, it went forward and then backward. But the loop composition algebra teaches a cleaner question. Did the counter-reform truly invert the first reform? Or did it create a new configuration that is not the original? In many cases, the inverse is not perfect, because institutions have memory. The reverse loop is not truly the reverse because the domain changed. New actors exist, old norms dissolved, trust shifted. That is exactly the point. The algebra tells you what you must track if you want to claim an inverse. If you claim undo, you owe the typing. Now, biology. Consider a metabolic cycle. A molecule enters a cycle, and the cycle returns the catalyst to its initial form. One turn produces a token, perhaps a tally of produced carriers. Two turns produce a composed token. If the system is in a stable domain, substrate abundant, enzymes intact, the tokens compose in a consistent way. But if oxygen becomes scarce, the domain changes. The cycle no longer returns to the same state, and composition fails. A biologist doesn't call that math breaking. They call it a regime change. That is the domain gate in living form. The sentence that was legal in one domain becomes illegal in another, and you must declare that. Now bring it back to the core. Loops are meaningful only if their tokens are composable. This leads naturally to the prediction and falsification inside PS0, purely grammatical. The language level prediction is the set of well-formed holonomy tokens assigned to loops in D with declared orientation and legal lift forms a consistent calculus under composition. That means composed loops multiply tokens, reverse loops invert tokens, decompose loops in different admissible ways, and the computed token is the same. The computed holonomy depends on the loop class, not on the decomposition. The language level falsifier is find the loop in D and two admissible decompositions into subloops, both properly typed, both staying inside D, both using allowed equivalences of lift and chart, such that multiplying the holonomy tokens of the parts gives different results for the same overall loop. If that happens, you have a contradiction inside the language. Either holonomy was not well defined, or composition is not a valid grammar. In either case, the language fails. That is falsification in a pure grammar, an internal inconsistency under the rules. Notice how clean this is. We did not need to talk about data or instruments. In episode 13b, falsification is first of all grammatical. Ill-formedness, invariance failure, domain contradiction, co-cycle failure. This part installs one of those, composition failure. Now I want to give you one more vivid image that can carry this part for a long time. Imagine a weaver at a loom. A pattern is not one movement. It is a composition of movements. The shuttle passes through. The comb beats the thread. The hands adjust tension. Again, again. Each pass is a loop-like action, a traversal that returns the loom to a ready state for the next pass, but with a new line of cloth produced. The cloth is the global record of composed loops. The weaver knows something deep without speaking mathematics. If one pass is done, and then another pass is done, the pattern you get is the composition of the two passes. If you reverse a pass, if you unweave, you can undo some of the memory in the cloth, but only if you truly follow the inverse path. If the thread snapped, the domain changed. You cannot keep weaving as if nothing happened. You must tie, repair, or excise. Otherwise, the pattern becomes inconsistent. Holophase is the same discipline, but applied to the most minimal global tokens available in the PS0 alphabet. We are not saying what the cloth is in terms of later physics. We are saying, if you claim the cloth has a pattern at all, you must be able to compose the passes. If you claim global meaning at all, you must be able to compose loops. Now, one subtle point that matters for the listener. Order matters. Composition is about after. Even in cases where the final token multiplication is commutative, you should never train yourself to forget order. Because the full grammar of loops is not just commutative arithmetic, it is a calculus of concatenation. You learn this in your body. Socks after shoes is not shoes after socks. Words spoken in one order do not mean the same as the same words spoken in another order. In biology, signal A then signal B is not always the same as B then A. The fact that we are discussing holonomy valued in U1 here does not justify careless habits. The safe PS0 habit is track order. Now we seal the part with a single sentence you can carry. A loop is a word. Composition is grammar. Holonomy multiplies and winding adds because A accumulates additively along joint traversals, and wrapping phase onto the circle turns addition into multiplication. And we bridge forward, because once you can compose loops, you immediately face the next question. When are two loops the same for the purpose of these tokens? Many journeys look different, but can be continuously deformed into each other without crossing defects or boundaries. If holonomy depends only on loop class, then we must define what loop classes are. That is the next step of the grammar: equivalence, homotopy, and the idea that global tokens do not care about the exact shape of a loop, only about what it cannot be deformed through. So part 20 is the moment the Pure Phi language becomes computable at the global level. It is where global meaning stops being a metaphor and becomes an algebra. It is where the language gains the ability to audit itself. If your claimed global token does not respect composition, then you have not found the deep feature of reality in PS0. You have written a sentence that does not type check, or you have left the clean domain without declaring it, or you have smuggled in a forbidden primitive. This is why this part is strict and why it is beautiful. It does not let us claim global meaning without paying the price of consistency. It does not let us speak about memory of loops unless that memory behaves like memory. If you do one journey and then another, the total memory must combine in a lawful way. If you reverse a journey, the memory must invert. If you describe the same journey in different segmentations, the memory must agree. If you leave the legal domain, you must stop speaking that grammar. In everyday words, the universe is not granting us permission to say anything we like. It is granting us permission to say a small number of things we can never contradict. Loop composition algebra is one of those permissions. It is the rule that says journeys add up, and the record of those journeys must add up with them. And if we respect that, we earn the next step, a classification of loops, a way to say which different looking journeys are in the same family. Because once the algebra exists, the most natural object to build is the set of all possible loop tokens and the relations between them. That is where topology becomes a real grammar, not a decoration. That is where, in the next part, same versus different loop becomes a formal question with an auditable answer. For now, hold the simplest image again. You return home after errands. The morning is one composed journey, because every segment connected stayed in a navigable domain and could be recomposed without contradiction. That is all we are demanding of loops in PS0. If your loops cannot be joined without contradiction, you are not speaking the Pure Phi language yet. You are speaking an untyped story. In this language, stories must type check. Salam. Peace be upon you.